Hello, today we're going to see the transfer line factory model taken from Professor Sky course. In this virtual environment, factory I/O. The model is composed, so you can see, of two machines, two buffers, and a test unit. So the first machine is represented by this conveyor with this arm and this positioner. Here is the buffer of one position, machine 2, it's a CNC, and the second buffer right here of 2 positions. Here, and let's see that this unit is simulated by a color sensor. In this case, we will not take blue as the correct color and green as a failed color, and all the pieces are generated randomly. And it's important to notice that if the color is wrong, if the piece has a mistake, it will go through these second groups of conveyors to be reprocessed. So, how can we model this? Now you're saying that all the machines in the test unit are modeled as a two-state automata, and the specifications that are right here. All the events that are with no numbers are controllable, and the other ones are not controllable. Now we want to make a quick overview over the code written to generate the supervisor for the transfer line plant. We will be working with the SC Supervisor library, which implements parts of the TCT software developed by Kai. So first of all, we have a dictionary where we define every event with a common name, with its direction and its state, both controllable and uncontrollable events, both physics and internal events. Also, we define all the masks for all the physical outputs of the program. Now we define a specific automaton for each one of the system components. As you can see, most of the automatons have two states and two transitions, with all of its states marked. Also, we define the requirements for the supervisor. For example, you can see the plant clamp just right here, and its requirement just here. Now you can see that both automata are defined just as we write it in the code, both for clamp and for its requirement. After we write all the local automata and the local requirements, we start to define the high level supervisor, the one who will be sure that all the process work in the best way. As you can see, we define machine 1, machine 2, and a test unit really close to the ideal model presented by Kai. There are some few changes in order to make it more realistic and useful for the digital twin, but in a sense they are pretty similar. Here you can see what the requirements of the buffers, and finally we generate every supervisor. We can also add a new specification. It's just for a start button that only allows a program to start after we press a physical button start. When we add this requirement, we only get an extra state with all the events just waiting for the correct event to start the process. Finally, we define all the local supervisors right here and all the related events. After this, we generate the SE code with this function with the name transfer line. It's found here. Let me delete it. Can run the code again. We'll see the code here is completely generated. Also, you can see some of the image of the process printed. Then we're gonna see the structured text code. So once again, let me delete this file so you can see it generated. Run the code once again. Now the file is ready. Now we can see first a function block of a random number generation. Then we have the variable block with all the variables that we need the code to function correctly. It includes the initial, the variable state, the random numbers, and also the falling and rising edge for the signals. Also, we have another variable block with all the physical addressing, all the inputs and outputs that we will be supervising. Then we can see that every rising and falling edge is related with a signal of a physical input. It's a random function, saving the random number into variable random num. And then, so we can see, we start to see all the uncontrollable transitions for each supervisor, all local and the decentralized supervisors. So uncontrollable transitions. Okay, then we can see a case statement, one for each supervisor. In this case, we see that the case number 0 and the state number 1 are the distributed supervisors, and as they have a conflict, the event related with inter 1 and inter 5 and inter 3 has to be supervised by the coordinator. So you see here the prefix G. Then we can see just the supervisors for all the local supervisors for every element of the plant, defined by itself, all their event generation, of course, all controllable events. And finally, we see a case statement from the coordinator, where it's enable or disable like here an event. Then we review that both supervisors and the coordinator agree to make a change in the system for each of the conflicting events. After that, just have all the controllable transition for each one of the local supervisors. And finally, we just have the code for the interface events right here, and the code for every mask, define it in Python. Not waiting more, we're going to see it working. We go here to Open PLC, let's go to Programs, Transfer Line, update program, just to take the last code we create. Let's see, right here, upload the program, give it a little moment so he verified that everything is okay. Go to the dashboard, review that the slave is configured, same IP, now here in factory, same IP, same port. Okay, that's perfect. Now we're gonna see him working. Just click play here and play here. In this case, we can see the part is green, so it will not pass the test of the test unit and will be reprocessed. That's a blue part. Now once it is a blue part, just correct and end the process and start once again with a random piece.